All right, so good morning, everyone. Thank you for joining us. My name is Sarah Husky with 3C Ren. I've started recording this course, which will be posted on our on-demand page. We are here today to talk about the changes coming with the 2022 Energy Code for non-residential projects. And we have Jennifer Rennick and Andy Pease from Inbalance Green Consulting.
Morning, everyone.
And before we get going, I just have a couple of slides to run through. We ask that everyone make sure they are on mute throughout the course. And if you'd like to verbally participate, please raise your hand in the participant section and we will call on you to unmute yourself. We also encourage you to participate and ask questions through the chat box as well. Next slide. So a little bit about us. We are the Tri-County Regional Energy Network, also known as 3C Ren. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. You may see a few 3C Ren staff members on the training today, and if you see anyone with this background, feel free to chat with them directly if you have any questions. So 3C Ren offers 3 programs. The first one is the Energy Code Connect program, which serves building professionals by offering Title 24 support for everyone from plans examiners and inspectors to architects and contractors. Within the Energy Code Connect program, we offer our Energy Code Coach service, which is an over-the-phone, online, and in-the-field support for Title 24 related questions. Another program we offer is our Building Performance Training, which serves building professionals such as architects, engineers, contractors, and real estate professionals by offering technical and soft skill trainings related to building science principles and high-performance buildings. And lastly, we have our home energy savings program, which incentivizes contractors and helps residents save money and make their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I'd like to introduce Andy to walk us through what to expect for non-residential projects.
Great. Thanks, everyone, so much for being here. This is the final of the 5-part series for this calendar year in terms of the 2022 Energy Code. Today, we're going to talk about how the code was reorganized, the high-level changes, and then get into the specifics for non-residential buildings, which also includes hotel, motel projects. So this is worth continuing education units. So if you didn't get a chance to enter your units, your AIA or ICC numbers during registration, Sarah can take care of you later. So we have going through single families, ADUs, the multifamily, and now we're at the non-res. All of these projects are going through a triennial cycle. So every 3 years, we have the California Energy Commission doing this great work. And they've been doing this since the 1970s. And it's been how we credit a lot of really important energy savings, cost savings, and ultimately climate action in terms of reducing our carbon footprint. It's a very iterative and inclusive process, lots of public review. And in fact, they're already starting on the 2025 code cycle. So the big picture goals for California for this code update and for the recent ones and going forward is basically electrification. We are moving away from fossil fuels, and that helps with our resiliency as well as our climate action. And so we're going into heat pump technologies more and more, electric ready. So for projects that are going fossil fuels, we're still going to have electric ready requirements. Super new for non-residential is requiring installation of photovoltaic and battery storage systems and ventilation. So that's kind of the big picture view of where we are. We're going to focus on the Tri-County climate zones. Of course, California has 16 climate zones altogether, and most of the folks that we find are often working throughout the state. So we'll highlight when it's relevant for those other climate zones, but otherwise our climate 4, 5, 6, 9, and 16 are the ones in our Tri-County region. So most important thing you need to know is that the building code is starting, the new update for the 2022 code starts January 1st. So we're just barely a month away, and in fact, exactly a month away. So all of those are available to download, and the 3C Ren has a wonderful resource library that has the efficiency standards and all the resources. Sarah touched on the Code Coach program. So there's a few, as you're going through today, there's a lot of the slides are kind of word heavy because we want you to know the details if you need to, and we'll provide a PDF at the end. We'll send that out after the presentation. So you'll be able to have access to that. And most importantly, Code Coach is totally free. So if you get bogged down in anything, just send a text, an email, make a phone call, and we'll take care of your specific questions. With that, we'll start talking about the code itself. I'm going to cover this first overview part, and then Jennifer will take care of as we get into the details and specifics for the non-residential section. So one significant piece is that there's a reorganization of the energy code. We used to have, or currently in our current code, we have kind of an all building section, and then high rise, residential, non-residential, hotel, motel, all those things jammed together, and then one section for low rise residential. And so what they've done is that was too much mashed up, and so they've added this multifamily buildings section. So to say this another way, they did it pretty smart in that we still have the subchapters 1 and 2. Then we have the not low rise sections that used to include everything in the low rise. The new organization, we have these 3 branches, but they kept the numbering. So you still have subchapters 3 through 6 for non-res, 7, 8, and 9 for single family res, and then new subchapters 10, 11, and 12 for multifamily. Today, of course, we're talking about not residential projects. So kind of our overall, what we're high level changes, we'll be talking about envelope and fenestration. Each time the code gets a little bit more stringent, and they review which strategies are the highest impact. So, and they have to be cost effective. So envelope and fenestration, HVAC, some lighting, some about covered processes. As we talked about PV and battery, that's new. And then remember that this includes hotel and motel. So some of the language will apply to guest rooms or non-residential spaces in general. And then just making sure we're all on the same page in terms of our language and what's going to impact you and what isn't. Mandatory, there's 3 compliance terms. Mandatory requirements, that's the one that applies to all projects. And then we have 2 ways to demonstrate compliance with the Title 24 Energy Code. The first is prescriptive. So mandatory measures are all still included, but you have this kind of recipe card in terms of insulation levels and equipment efficiencies and how much windows you can have and the properties there. So that's kind of our baseline. It's a checklist approach. Performance model is when which we're almost exclusively using, or it's the most common, especially for non-residential projects, in which you can trade. And so you put all of that into a computer model, and it tells you, do you comply? The reason why we spend a lot of time on the prescriptive package is because that's your baseline that you're going to be compared to from here on out. So if you understand what the prescriptive requirement is for insulation, then you know that if you need to go lower than that, then you need to be even higher someplace else, right? So if you know your baseline, you can start from there and either adjust up or adjust down if you need to. So those are two approaches. The other kind of groundwork is this, what our metric is for the energy compliance. So time dependent valuation, TDV, is what we've been using for a long time. And that takes into account not only how much energy you use, but when you're using it. And so that matters in terms of as our grid gets cleaner with renewable energy, it matters in terms of how much energy you're using in the middle of the day. And then we're starting to talk more about source energy and understanding when are we using carbon in the grid and when are you using carbon in your project. So overall, we're looking at our TDV energy, and we have this new metric called source energy, and it's a proxy for carbon. So you'll just see that more and more we're leaning away from the fossil fuels and ways to give you credit for doing the all electric and renewable. And just because it's the energy code and we're trying to keep it a little bit complicated, we actually have 3 metrics now, and you have to pass all 3 in order to comply. So this is a snapshot from a compliance form. And so we have the efficiency TDV, that's the building itself. The total TDV is the building efficiency plus the PVs and batteries. And then you have this third metric for source energy, and that takes into account more of the carbon footprint that your building is going on. Jennifer, do you want to say anything else about that? Did that cover it okay?
I think you covered it great. I think on the source, just maybe on this example, I'll mention that this was a mixed fuel example. And when I did it as like all mixed fuel in a different climate zone, all 3 passed, including the source energy. But then I took the same office building and put it into climate zone 4 to see how it would perform. And then the source energy portion didn't pass, but it was still energy efficient, and our total TDV with solar and PV was there. So I could have switched fuels. I could have looked at better insulation. And in this case, it was just as easy to add like the equivalent of 3 more panels, electric panels. And so I mentioned that because I noticed a lot of architects on the call. So when you're working with your energy consultant on some of this, or your mechanical engineer, whoever's doing this part of your project for you, just know that you might have some of these other options come into play.
Cool, thanks. Another tool as you're going through your Title 24 reports, it's good to understand what areas, if you're not passing or you're passing by a lot, like where. And so the energy compliance modeling breaks it up into these categories. So there'll be a proposed your standard design, what's allowed by that prescriptive measure that you're being compared to, and then how your building performs in each of these categories: heating and cooling, ventilation, so that's allow your fans, water heating, indoor lighting, and now new solar PV and battery storage, and then the covered process loads. And interestingly, those standards and the prescriptive are not the same for every climate zone. So they're really, most of them are like heat pumps are now the prescriptive baseline, but not necessarily every climate zone is going to have some variation there. And so with that, I'm going to turn it over to Jennifer to talk us through mandatory measures, prescriptive, and the rest of it. Thanks.
Okay. This part of the code, for mixed occupancies, I put it in here for reference, and you're going to get a copy of the slide deck. And I'm just kind of as a reminder that usually for non-residential, we take a look at each occupancy type and can have different rules apply to it. And so this part of the code is still the same. And those exceptions being is, for example, if 90% of the whole building falls under your non-res occupancy type, and you have, say, storage project where it's all storage, it's all non-res, except there's an on-site dwelling unit. Well, the on-site dwelling unit would need to comply with the lighting requirements for dwellings in that, under this rule. And otherwise you could run it all under the non-res standards. So that's for reference. And it'll come into play when we get into some of the other part of the code. And the big change across the board that affects all occupancies is just there's been equipment efficiency updates. And those are in section 110.0 through 110.6. So if we have any of the mechanical engineers on the call, when you go into those sections, you'll see that there's many more charts and equipment and efficiency levels. And mostly this is going to affect the non-residential spaces, and mostly medium and large capacity systems. So some of those efficiencies have changed for some of the cooling systems, cooling towers, furnaces, and boilers starting kind of mid-January. And there's brand new tables now for dedicated outdoor air systems. And for those of you who aren't familiar with that, it's essentially a separate small duct system that deals just with the ventilation, fresh outside air. There's now new tables for fan efficiencies for that, efficiencies for computer rooms, electronics, and now heat pump and heat recovery chillers. As far as the windows go, there hasn't been a lot of changes on U factors or U values or the thermal performance. But one of the big changes is, oh, sorry, we'll get to that on prescriptive. One big change is that it's now divided up by climate zone. But under the mandatory measures, we used to be able to have windows, a certain amount of the windows that we could use a center of glass formula to calculate the thermal performance of that window. And that has gone away for vertical fenestration for windows. And now all the windows you're going to use in your projects essentially are going to be NFRC rated. And you can still use that center of glass for specialty skylights less than 200 square feet of area.
And Jennifer, I just realized we're using an abbreviation without actually spelling it out anywhere. Is that the National Fenestration Rating Council, NFRC? Correct. Is that right? And they're the ones that, have that standard. Yeah. Okay.
Right. And then SHGC, solar heat gain coefficient, and VT, visible light transmittance.
Perfect. Thanks.
For our lighting changes under mandatory measures, there has not been a lot of changes, except one change potentially could have some impact for what is being designed for by your electrical lighting engineers. And it used to be that lighting systems with that were part of a office or other spaces that were 10,000 square feet or larger would have to have demand response controls. And those are those specialized controls that can communicate with your utility company and dim down those lights if we're needing to conserve energy during potential brownouts and blackouts and that kind of thing. Now the threshold's been shifted to 4,000 watts or greater rather than by a square foot number. And to put that in perspective, using an office building as an example, that 10,000 square foot office building might trigger, or a 10,000 square foot warehouse or retail would trigger for sure. But now like 4,000 watts, you could easily get that in a 7,000 square foot office building. And you could easily get that in even smaller, like a retail or warehouse. It might be around 6,000 square feet. And there are some new controls too with the receptacles, meaning that if your building has to have the demand response for the lighting, now that's going to affect certain receptacles. And the lighting demand response still would have to reduce everything by 15% or greater.
Jennifer, before we move too far from the fenestration one, somebody asked about under this NFRC about storefront systems. If this NFRC is tied to not just windows, but storefront. And that's true, yes?
Yeah. Yes.
Okay.
Yes, you can still use default values, but they're very, very poor. And you would have to use the performance method to use those default values, and you will be doing a lot to try and compensate for how terrible those values are. So you're just about, I'd say across the board, you're essentially going to be speccing out NFRC rated windows, storefronts, curtain walls, the whole thing. And then the manufacturer of that window assembly, they're now able to use specialized software to develop even temporary labels so that you do have that label. It's just that they used to be able to avoid some of that up to 1,000.
Uh-oh, we lost you for a sec, Jennifer.
Glass, but now
Jennifer?
then
Sorry.
it got
yeah. Jennifer,
we're down. So,
Jennifer, we're starting to lose your sound a little. I don't know if you want to
okay,
switch to phone or maybe turn off your video. See if that helps for a bit. And then also just I'm
going to click off my video.
Okay, cool. And we'll try not to get too distracted and save time at the end for questions, but if you do have something kind of quick and burning, feel free to pop that in the chat and we'll pause as we get there. So, all right, thanks for that. Okay.
Okay, so probably the biggest change on the indoor lighting controls is there's clarifying language that you can use scene controllers now, as long as the scene controller is able to do what it's supposed to do to meet the energy code. And automatic daylight controls are now mandatory for the secondary daylight zone. So basically, some things that were prescriptive are now mandatory. On the ventilation side for HVAC ventilation, basically, there hasn't been a lot of changes other than now saying that the equipment has to have better diagnostic capabilities for showing that the equipment is going to meet the 10% designed, kind of within 10% design of outside air that used to only be applicable to constant volume single zone systems, but now it's applied across the board to variable air volume systems as well. So this stuff, as architects, you may not see any difference, but the mechanical engineers are going to need to be aware of it. Duct leakage testing has changed a little bit, and duct leakage systems now, it's clarified that you have to have a HERS person verify the duct leakage to no more than 6% if it's serving less than about 5,000 square foot conditioned floor area and having more than 25% of ducts in unconditioned space or outdoors. So that used to not be as clear in the code, but now it's spelled out and it's become a mandatory measure. And there are exceptions to that, such as healthcare facilities. For those of you who are working with process boilers, compressed air, and the steam traps that go with the process boilers or large heating boilers, The threshold for efficiencies and has dropped from being a capacity of 10 million BTU hours, dropped down to 5 million BTU hour. And they're basically now requiring default diagnostics on the steam trap for those for that capacity boiler greater than 5 million BTU. And it's a cost-effective way for projects to save energy, because the California Energy Commission determined that many of the steam traps were failing and causing a lot of blow by and condensate to get into the system, and creating a lot of unnecessary heat loss and equipment degradation. So now this is a mandatory measure. For the computer rooms, and computer rooms are defined as conditioned floor area with any of the electronic equipment having a 20 watt per square foot of connected power density load or higher. And now the equipment that cools these computer rooms have specific controls for not allowing reheat and energy efficiency and capacity limits on the motor demand. And for the controlled environmental horticulture, CEH spaces, specifically this was targeted for cannabis growing, and not like greenhouses where you're growing for decorative plants, but cannabis growing. There's some new mandatory requirements on efficiencies, and a couple of the key highlights is that the grow lights have to have a special type of high efficiency, spectrum efficiency with dimming and time lock controls, and the dehumidifiers have to meet special federal dehumidifier standards now. And if you're doing a conditioned greenhouse, the glazing system has to have at least 2 layers, be dual paned essentially, or dual plastic glazed.
I think this is hugely important, right? It's quite an energy user, this industry. So I think these are some good
right. It turns out that, I mean, if you really, I don't know if any of you on the call have worked on the cannabis projects, but the few of the ones that we have, they stack the plants up, so it's as solid plant material as possible. Lots of lights, lots of grow lights. They'll run them 24/7, plus strategically control the exact amount of humidity or dehumidify or add humidity, and all those systems, it turns out, was using quite a bit of energy. So we're going to go into some of the new construction side of it with the prescriptive, and touch a little bit on how that affects performance. But the reason, like Andy said, we're going to hit on, it's okay, you can click forward. We're going to hit on the prescriptive is because it becomes the baseline for your performance calculations for your computer modeling. And this part of the code, it's organized as kind of building envelope, conditioning spaces, water, heating, indoor, outdoor lighting, signs, covered process, and last but not least, the photovoltaic and battery storage systems. I'm going to run through a couple of the highlights on how the building envelope has changed, or at least how the code now is being organized. And we're going to touch a little bit on some of the changes on indoor, outdoor lighting. And then I'm going to spend a bit more time on the brand new section for photovoltaic and battery storage systems. For our envelope, they're basically for roofing products. The main takeaway is that there's some new requirements for steep slope roofs and different trade-offs for the low sloped roofs. And they basically kind of increased the solar reflectance and increased the minimum age solar reflectance so that the roofing systems are a bit more energy efficient. And now they've broken it up into climate zones. And the trade-offs for the solar reflectance is increasing. The effect is to increase the insulation now for that trade-off.
And Jennifer, is it fair to say in terms of we end up with these three metrics, the solar reflectance, the thermal emittance, and then the solar reflectance index, and the SRI is a formula calculation based on the other two, right? So a roofing product might have the first two or the SRI, and either one works. Is that, am I saying that right?
Yes.
Yeah.
Yes, correct. Thanks for mentioning that. Okay, you get on the envelope for prescriptive tables. There has been some changes to the metal framed walls. And Andy, go ahead and click it so the arrow points up. And then there's been a little bit changes on that minimum requirements for the age solar reflectance and thermal emittance that we just mentioned in the previous slide. And then the other kind of significant change is now air barriers are required in all climate zones prescriptively. And the air barrier, it could be even be like taped drywall, but use an office building as an example, or retail stores. We have seen situations where they might have a dropped ceiling, but then the attic, the quote unquote attic, is ventilated to the outdoors, because the thinking was that, oh, you have to let that moist air, once it gets through that drop ceiling, get out and go outdoors. But those days are gone. What they want is a hard ceiling or a hard line. It could be up, it could be at the drop ceiling, that could be a lid, or it's got to go all the way up to the roof and include the entire envelope with the air barrier, so no air leakage and no holes to the outdoors. And then we take care of all the rest of it through mechanical ventilation means. I'm going to give you an example of the significance of the change of that metal framed U factor. And just to kind of remind y'all, the U factor is, oh, well, maybe I won't. You just click to the next slide, and I don't know if that example's in there.
Yeah, maybe we didn't put it in.
Okay, well, I'll just verbally tell it to you guys, and then I'll include it with the slides you get with the slide deck. But this U factor has decreased, which means the insulation level R value has increased. And now, for example, climate zone 5 in San Luis Obispo, or climate zone 4, got a U factor of 0.055. And if you're going to use a metal framed wall to get that to comply prescriptively, you'd want to use like the equivalent. Let's say you're using the equivalent of a 2x6 metal framed wall. You're going to want to use the spacing 24 inches on center, and to fill that cavity with a high density bad insulation or other material that's going to give you your highest density. So you might have an R21, could get up to an R23 in there. And then you're going to clad the outside of that with like an R12 insulation.
R12.
R12.
Rigid insulation. Wow. So
yeah,
that's like
could be right. It could
2 or 3 inches.
And then the climate zones that are more mild, like climate zone 3, that's the mildest one now. It was 0.071. That one only needs like an R8. So like 2 inches of insulation. So if you're going to use metal stud walls, you pretty much are looking at some kind of insulated paneling system or other means to get that exterior insulation. And or you have to do as much as you can and then know that that metal frame is going to take a hit under the performance method, and you're going to have to look at other ways for making up the difference.
And wood frame in commercial, is there also going to typically be at least some rigid, continuous rigid insulation, or wood frame doesn't have as much thermal bridging? So I know in residential we usually do, but.
Right. So for some of the climate zones, like climate zone 4 and climate zones 9 through 16, those climate zones, yes, you could use some rigid insulation, or you might still be able to mitigate with like a layer or two of something like Den's deck, and then use the performance method to work around the rest of it. But
Okay.
yeah,
Thanks.
or like a you know, like an R2 value of insulation.
Great.
But the metal framed walls, that's what's changed. The wood frame is the same from the last code. The fenestration values, really what they've done is like your maximum U factors haven't changed that much, but what has changed is that it's now slotted into different climate zones. And you can, for the fixed windows and the curtain wall or storefront systems. But the actual value for most of us, we're dealing with a 0.41 U factor on curtain wall and storefronts. And that's pretty much the same, except for in climate zone 1 and climate zone 7, where it's determined that it was important to have a better U factor and slightly lower solar heat gain coefficient. Okay, for space conditioning systems, the main kind of takeaway here is that a lot of heat pumps are now the baseline for when you do your performance method. So it shows up as a prescriptive requirement. And it's a little bit nuanced in that it's building type and climate zone dependent. So I tried to put this in a easy to reference format for you. You'll get a copy of the slide. But for example, if you're going to be working on a school building now in climate zones 4, 5, 6, 7, which is part of our tri-county area, the baseline is a heat pump. And along with that is new calculation methods for the fan power budget. And there's, this is just an excerpt of the table. And this continues on quite a bit in the manual. So if you're a mechanical engineer on the call, you're definitely going to want to look through all the tables, and you would enter the table, you know, based on whether it's a VAV system and, you know, how the square footage that you're conditioning, or rather how much CFM of volume of air you are conditioning for that. And then on the other part of the column down left, then you're going to look in there and figure out whether it's like, for example, the top one, serving space is less than or equal to 6 floors away. And that's where the size of the building comes in. But it also kicks in too, whether or not you've got a MERV 13 filter or higher upstream of the thermal conditioning equipment. Plus 2 times the clean filter pressure drop, et cetera, et cetera. So it's nuanced. You're going to want to take a look at that. Same concept with economizers now, specifically addressing more what's allowed for economizer trade-offs and exceptions that are provided when you're using a DOAS dedicated outside air system with exhaust heat recovery. And the kind of the big takeaway is they're just broadening the application of requirements for economizers to lower capacity units. And when it comes to the high capacity space heating gas boiler system, so this is now a system where you would not go all electric, you're using gas, natural gas is the fuel. They're saying, well, if you're going to still need natural gas for these types of systems, then the boiler efficiency has been bumped up to a 90% minimum thermal efficiency. And the threshold for that on the equipment has been lowered, and it is climate zone specific. There are a few exceptions, and the basic design impact for the mechanical engineers is they're going to have to consider your system layout. And that's partly because boilers within the same building, but on separate loops, are not considered to be part of the same system. So you have some, trade-offs that you can do there with efficiency and how the whole system layout is set up. For those dedicated outside air systems, there's just been clarifying language and now specific prescriptive requirements for the dedicated outdoor air systems. And the main takeaway is that they don't want these systems to heat and reheat and to waste energy. And so it's just spelled out a little more. And for those of you on the call who are not familiar with dedicated outdoor air systems, a lot of times, especially for small projects, the ducts can be very small. And that's an example of a system that was in a project that was under 5,000 square feet. And they have a return and a supply, and this small ducted dedicated outdoor air system functions independently of the heating and cooling ductwork that you may have. So you probably will have heat pumps for that heating and cooling with its own small, relatively small ducted system. And then you now have another system that deals just with the outside air. And it can involve heat recovery or energy recovery systems to conserve even more energy. But now they've said, okay, if you're going to do that, you have to meet certain fan efficiencies to go with that system.
This all makes a lot of sense, right? Because as our buildings are better insulated and performing better, we have smaller heating and cooling loads, but we still have the ventilation requirement. So by decoupling those two, we're able to get better efficiency out of each one, depending on the different demands.
Yes, that's right. And for those, for that exhaust side on the air heat recovery systems, these new tables are included, and they're have efficiencies spelled out per the amount of cubic feet per minute the system is moving. And it's kind of like a heads up. But again, the mechanical engineer on the call is going to have to go and really look at the tables and see what the implications are. And the architects and the other designers just know that that's something your mechanical engineer is going to be looking at now. And same with the understanding the prescriptive design criteria for these systems. And they're saying, okay, they've got to have a recovery ratio of at least 60%. There's other requirements on controls and bypass controls. And all of this is set up now just to make sure that the system isn't unnecessarily using extra energy. Because the idea is to use heat recovery And heat recovery, for those of you who are not understanding that term, it means that as an airstream, say, leaving the building is filled with warm air being exhausted out of the building, the incoming cold air, let's say we're in heating mode, the incoming cold air can go through, not mingle directly, but touch through a thin membrane that warm air and transfer the heat into the cold air. So now the cold air is tempered. It's not as cold, and you're introducing that to the building, and that warm air that you were exhausting has now been cooled off because its energy has been transferred into the supply air, and it leaves the building, thereby saving energy. But if the fans use too much energy in and of themselves, it's not a net gain of energy savings. So a lot of these requirements now are to dictate that your heat recovery system has to have a certain efficiency in the first place, and the fans have to meet certain efficiencies, and you have to do other things with the controls to make these work.
And another key point about those heat recovery ventilators is that the efficiency really makes a difference in how well your building complies for Title 24. And so if you're not passing and the report, bumps up that efficiency, then you're passing, but then you got to make sure the actual equipment installed is in alignment with your Title 24 report. And I think a lot of folks aren't necessarily used to looking for that piece of that number for the efficiency rating of the unit itself for heat recovery.
Oh, yes. Andy brings up a good point. Spoken from experience.
Yeah. We share the learning curves of the industry.
Okay, there's been a little bit of changes on the domestic hot water, and mostly an increase in efficiency up to the 90%, which implies like a condensing boiler efficiency. And again, that's based on how large the system is. And, the exception still is, for example, in other occupancies, if that individual bathroom space, you could still have the instantaneous electric heater right at those bathroom sinks.
Good thing.
Oh, I think I back up one. School buildings. This one's probably worth mentioning. When you do have a school building and it's under the 25,000 square feet, under the 4 stories, in many of the climate zones now, all except for 1 in 16, heat pump water heater system is the new baseline, either prescriptively required or becomes the new baseline for your performance calculation. Indoor lighting, there has really not been many changes on the indoor lighting. A few categories have become a little more energy efficient, and I haven't noticed that this is going to be a problem because so many projects use LED lighting anyway. But where you might notice this on the performance method is if, as an architect or mechanical engineer, if you're always counting on having a big cushion on your electric lighting, part of the LPD, lighting power density budget, some of that's going to go away. So you can't depend on the lighting making up for the rest of the performance. On the outdoor lighting, probably the most kind of significant change is if you're doing outdoor lighting calcs, the kind of that baseline, that perimeter calculation has changed. It's gone away for part of that formula. Also, asphalt and concrete are no longer differentiated on your hardscapes. but probably one of the most significant changes, and I'm not sure what kind of an impact it'll have for you, is now we have urban clusters and urban areas. So when you're looking at your lighting zone designations to determine your threshold, you're going to see these two categories. And in order to know where your project lands with those new categories, you will need to look at the 2010 US Census. That's the baseline for understanding whether your project is considered an urban cluster, an urban area. And if it's not designated as those two, it's automatically rural. When it comes to the computer rooms, same, again, greater than 20 square feet, 20 watts per square feet. And there's some new language on it and new efficiencies in COP, coefficient of performance, based on climate zone on the equipment. So that part's new. Same kind of idea. Now we're dictating efficiencies on the UPS or the uninterrupted power supply for all that equipment. So there's a new table, and these are now based on your connected load rather than climate zone. This whole section for solar access roof area is SARA, is a new term. It's a little bit related to what we used to do to show that a project was solar ready. So, but now we've got solar accessible roof area. And this, I think we just go on. It's defined as a solar accessible roof area. So where that comes into play is on point number 2 down there. And it comes into play now with determining how many PVs, how many solar panels you have to put on your new building. This is for new construction only, brand new construction. And there are only certain occupancies that are affected. And this is based on climate zone. So if your occupancy is grocery or high-rise multifamily, office or institutional, unleased tenant, retail, school, warehouse, auditorium, convention center, hotel, motel, library, medical office building, or a clinic, restaurant, and theater. If you're working on one of those projects, then you need to come take a look at this table, and then based on what climate zone you're in, gives you a factor that is used in the formula based on your PV system size will equal your conditioned floor area of that space times one of those factors, divide by 1,000 to convert to kilowatts. Or you're going to take that Sarah from the previous slide and multiply it times 14 watts per square foot. Also, if you divide that by 1,000, you'll get kilowatt hours, or the kilowatt system. So I ran through an example here for you just to see what that looks like. And those PV requirements are additive. So for the portion of this building we worked on, there was about 2,000, and I just used round numbers for the example. There was about 2,000 square feet of restaurant, 3,500 square feet retail, and there was still 7,000 square feet of office and some unleased spaces. So I used those factors from the other table, and I came up with a kilowatt PV system of 33 kilowatts. Or I know from the previous calculation, we had a Sarah of 4,500, and it turns out that 33 kilowatts is smaller than the Sarah calculation. So we get to choose the 33 kilowatt system size. And if you're, for the architects on the call, if you want to kind of get an idea of what that might look like, you would find a commercial panel that's one that you might likely use. You find out how many watts are in that commercial panel. In this case, it's 470 watts. I look at the dimension that's also given for the panel, and I almost always add a 1/2 inch, sometimes more, to the panel to accommodate for the mounting hardware. And I can come up with a panel size and start laying it out, or I can determine the area in square feet of that panel size, including the cushion around the panel. And I can start to determine how many panels I need and also the square footage of that system. And in this case, for this example, you need 91, or wait, sorry, actually it's cut off on there, Andy, on my screen. Did I remember that right?
Yeah, it's 71 panels.
71, I said 91, 71 panels, that's right. Yeah, call
Right.
it 71. And then you can start to lay it out.
And I think it's important that we have those two formula options, because a building that is multi-story with and dense might end up with, if you just do the conditioned square footage formula, you're going to have too big a system. So to be able to, which works for, but a sprawling warehouse is going to be beneficial with the other formula. So by having two options there, it makes a lot of sense to be able to optimize your solar, your renewable energy system size. That's
right. And there are exceptions. And so if it turns out, for example, you have a SARA that's less than 3% of the conditioned floor area, it's exempt. If you have a system size that ends up being less than 4 kilowatts DC, exempt. That's, it's a small building if you have less than 4 kilowatt DC, but it could happen. So really small buildings, or if that SARA ends up being that it's less than 80 contiguous square feet, there's some exemptions. And then the exemptions for snow loads, which we don't really have in our area. And if your project is actually part of a community solar program, not that your utility is community solar, but I mean, if your project has a physical location for PVs that are specifically for that maybe developer and specific to certain buildings, it's possible that you can use that offsite PV system in lieu of putting PVs on site. And then for battery storage, there is a similar situation, and then that you use some math to figure out how much battery storage you need based on those same occupancy types. But it's not based on climate zone, just straight up occupancy types. And you can do it if you're the architects or mechanical engineers, or you might have your electrical engineer look at this with you or for you, but it begins to tell you what size PV battery system you need based on the rated capacity of your PV system that we just calculated in the previous calculation. And when you look up batteries, there is something called D, which is the rated single charge discharge cycle. And for like a Tesla battery, that's like a 0.95, and some other batteries, it's a 0.8. But just give you an idea that when you take that to the half power exponent, it's essentially going to give you a number that is going to increase that B factor like 120%. So you can just kind of estimate that and get a size just to get you started. And there are some exceptions for the batteries as well, so that if you end up with something less than 10 kilowatt hours, for example, you don't need to do the batteries. And if you happen to be working in a project that's in climate zone 1, there's no battery storage requirements for offices, schools, and warehouses where that was determined not to be cost effective. For additions and alterations, we have a few slides here just to kind of hit on a couple of the highlights. But if you are working on additions and alterations, typically this part of the code section is fairly nuanced, and you'll want to go into the code section and just really, it's not very many pages long, but it really just depends on what you're doing. So it's like, well, I'm completely replacing the HVAC system. Okay, what are the requirements? Oh no, I'm only doing a duct extension, for example, to serve an addition that's less than 5,000 square feet. Oh, okay, if that's the case, you only need to seal the ducts and HERS test it to less than 15% leakage, versus all new or replaced ducting systems, then you would test it to 6% leakage. And there's a few requirements for hot water alterations and new different supply fan power allotments based on the particulars of your heating and cooling system. And there's an excerpt of one of the tables that is in there. So new tables, again, if it's an addition alteration, I suggest you just look through those pages and start to see what your project is covering.
Or reach out to Code Coach because it's confusing.
Yeah, or reach out to Code Coach. And on the roofing alterations, the trigger is still when 50% of an existing roof is being replaced or recovered, or 2,000 square feet of existing roof is replaced or recovered, then these insulation for the roof is triggered. And you also need to really take a look at whether it's steep angled or low sloped roof. And the end result is that there are higher levels of roof insulation, such as, requiring or triggering an R10 above the roof deck. And that can be kind of significant, especially if that's combined with whether or not you're removing HVAC equipment and re-roofing or leaving it in place. And there, I think that's on the next slide. There are some, perhaps after that, or if not, I'll just tell you verbally that there is, it's nuanced in that when you're lifting that equipment off, then there's a certain requirements for how you're dealing with the re-roof. And if you're leaving it in place, there's a different requirement. But also, if the insulation thickness doesn't make your equipment work out so well when it's left in place, because the thickness might be taller than the curb, and then you end up with some other issues, there are exceptions for those types of situations. And those situations are explained pretty well in the non-residential and multifamily compliance manual. So I do recommend that you take a look at the manual if you're doing additions and alterations, and not just at the code section. So I do think they do a good job. And it's my tip down at the bottom. That's where I put it. They have the alteration scenarios and potential cost-effective solution considerations, especially for roofing and HVAC rooftop units. It's really good. And with that, like Andy said, you can always use the Code Coach service.
Right, and that's the That's our content for today. We just have a couple of slides to wrap up, and then we'll open it up for any kind of questions or comments that folks have. This is always a good time to exchange ideas and experience, as well as address specific questions. But Energy Code Coach, it's available for jurisdictions. So if you have building departments, plans examiners, inspectors with questions, for design professionals, for builders, it's really anybody who has questions both about the energy code, but also about the Cal Green Code, which has some new requirements for electric vehicle charging and things like that. So I encourage you to do that. And then with that, I turn it over to Sarah to close us out.
Yeah, thank you. So before we open it up for questions, there are learning units available for today's course for AIA and ICC. I'll be submitting those once we're done with the course today. So if you have your number that you would like to provide to me, my email is there on the screen. If you added it in registration, then I already have that and I can go ahead and submit on your behalf. Coming to your inbox will be the slides, the recording, and a survey from today's course. And then today is the last course of 2022 from 3C Ren. So our upcoming courses will be in 2023, and we are working behind the scenes, hard at work, getting our calendar ready. So stay tuned for our Q1 and Q2 calendar for next year. And with that, can open it up for questions. I actually received a question in the chat that I can bring. So the question is, Neil has a project that has a primary use of generating electricity on a large canopy covered with PV. Is there a battery storage requirement for that type of use?
The battery storage requirement will be for based on the occupancy type. So if the PV system is required because of that occupancy type, there will be a battery storage requirement to go with it. But if you're putting PVs on a canopy and there is no corresponding occupancy type requirement, then batteries are also optional. Did that answer your question?
It does. Thank you.
I was going to say, feel free to turn on your cameras or unmute and ask away.
Yeah, definitely.
Thank you.
You're welcome. That's it.
Jennifer, are we seeing yet kind of the battery, like how much space and where architects should be making room for batteries? Are those typically going to be inside a storage room, or they're outdoor rated and far away from a building? What's the kind of guidelines in terms of accommodating these battery systems for non-residential?
That's a really good question. And some of it depends on the type of battery, but a lot of the really kind of compact batteries that we think of, maybe kind of the most name brand recognized is like, you think of like a Tesla Powerwall type of battery, real compact, very, very heavy. There's other manufacturers, many manufacturers out there that make that type of battery system. And those they don't want to get too hot, for sure. They don't want to get too cold either. So protected locations is good. We've noticed, like, looking at potential battery requirements for some of the high-rise multifamily. And in those cases, they want a room. They want it just part of their whole mechanical room system with good ventilation, because they want to make sure everybody stays out of it and doesn't touch it, doesn't get near it, those kind of, requirements.
So electrical room is a good type of location.
And they need a certain amount of space around them, but mostly, like a lot of equipment, you need at least 3 feet in front of everything so that you can work on it. In case, you have to change things out. So it's like all our mechanical and electrical engineers tell us architects, give me space, please.
Right, it's the constant battle.
Maintenance.
Right, everybody's competing for space.
Yeah.
We had a question in the chat, eating guidelines for PVs on non-residential buildings, not specifically listed in the table. So if it's not on the table, I mean, that table seemed like it included just about everything that most folks are working on. So,
I
but
know
if it
it's
isn't,
tricky.
then you don't have to, right? And then
If-
maybe you do it, whatever is close enough, because PVs pay for themselves and they help solve climate crisis. But like a
Right.
public, like what's the categories for a public safety project? I know that comes up sometimes. Is that public safety as a category, or is that like a warehouse and an office type of, or a garage and an office or something?
Right. So they're basing it on, the UBC, those occupancy types. There's another part of the code and the administrative part that says, you're going to look it up and use it by your building type that architects use for determining that UBC occupancy.
Gotcha.
And so if that safety building, it has office, that's in there. If it has,
Sleeping quarters has a category, right?
right,
Whether
sleeping
it's
quarters,
res or-
dwelling
Mhm.
units. So is that part of it? Are you looking at that like, what kind of occupancy? Is it low rise residential, but still multifamily in that sense, or multi-habitable? You might
Yeah.
have to use the residential standards, which has a PV requirement already.
Right.
So
Okay.
we're going to have to tease that out. I suspect there's going to be clarification on that coming up from the CEC as some of this comes through. I don't know. Sometimes we get someone from the CEC on our calls and they'll know, and sometimes let us know that, oh yeah, we're addressing that in a future blueprint publication. But I think there's going to be questions on really honing in on how you calculate the SARA, the outdoor area for solar, especially if you're tight and you want to use that as the more restrictive value than your conditioned floor area. In some cases, I could see that coming into play. It says that the code, it says, well, you can't include the SARA that has shading, or when you're looking at solar ready, it would explicitly say you can't have, your building shade part of that zone and then count it, but it doesn't really spell out the other way around if a designer just designs it so like the whole dang thing is shaded, just cuts.
Right. Yeah, if you
Right?
put such a huge parapet that you don't have any unshaded roof area, well, you shouldn't get out of your solar requirements based on that. So, but that's a hard one, right? Because sometimes you have to for, like a zoning code might have a parapet requirement for visibility or something. So
Right. And then it's not, but the code does say that for the SARA, you have to include all structures that are capable of holding PV. So for example, if your project also has like a large canopy that might be used for covered parking or protection for vehicles that might be driving under it, or for some other purpose, like that is structurally capable of holding PV. So you have to include it. So I'm sure there's going to be situations coming up, but the intention is that those occupancy types have a PV requirement. And then the other intention is that they realize, like Andy was saying, if you have a big, sprawling, long, low, single-story building, you have so much roof area to work with, it doesn't make sense that you would have to do 14 watts per square foot of that roof area that's accessible to the sun. So it's based on the occupancy. And then the other is true. If it's really compact but really tall, because that's what your lot and your code, jurisdiction allows, then you would just put as much PV as you can that has the solar access.
Great. Any other questions, comments? Not, we'll linger for a moment in case anybody wants to ask a direct question, but otherwise we'll let you all go and look for an email in your box that's coming.
Yeah, and
Thanks
I'll
so much,
add
everyone.
I'll add that
Oh,
slide.
yeah, well, tuck a couple new ones in too. Thanks, everyone. Have a great morning.